America is sinking, and it's not due to the tariffs. It's due to a geological change. The entire North American continent is slowly sinking.
What if I told you North America is about to face a massive change, and you're hearing it first? It looks solid and unbreakable, but deep below the surface, the continent is slowly pulling apart. Huge cracks are forming. Ancient faults are waking up. Parts of the land are already moving in different directions. Scientists are watching the warning signs grow stronger, especially in the western United States. The pressure is building. But how serious is this? And what could it mean for the future of the continent we call home? When the world breaks. At first look, the Rio Grand Rift seems harmless. The landscape feels peaceful and wide open. There are broad valleys, flat desert floors, and long lines of mountains running across the horizon. Nothing about it appears threatening. It looks old, steady, and shaped slowly over time by wind, rain, and flowing water. But that calm appearance can fool you. This region was not created by surface forces alone. Far below the ground, deep forces have been pulling the land apart for a really long time. Beneath the quiet scenery lies a massive split in the Earth's crust. It begins in central Colorado and runs south into northern Mexico. This hidden break is one of the most significant and still active geological zones in North America. The Rio Grand Rift is not a quick break or a sharp tear you can watch happen. It moves at a very slow pace. Still, it truly exists, and it has not stopped. Even now, the ground beneath North America is being pulled apart from side to side. As this pulling continues, the rock layers grow thinner and lose strength. Slowly, huge sections of land drop down, creating wide, low areas known as basins, while nearby sections are pushed upward and become mountain ranges. This steady movement is what created the landforms we see today. This rift runs for more than 1,000 kilometers. It begins in the San Luis Valley of central Colorado, passes through New Mexico, and continues into West Texas and the Mexican state of Chihuahua. Along its path, it has created some of the most striking landscapes in the region, including the Albuquerque Basin, the Española Basin, and areas near Taos and Socorro. One of the most interesting things about this rift is that the Rio Grande River follows it closely. From southern Colorado to El Paso, the river flows right along the weakened zone in the crust. Only near El Paso does it turn southeast and head toward the Gulf of Mexico. The river's path is not random. It is guided by the deep structure of the earth below. The rift also marks a major boundary inside the continent. To the west lies the Colorado Plateau, a region of high, relatively stable land. To the east lies the interior of the North American Craton, the ancient and very solid core of the continent. The Rio Grande Rift separates these two regions, acting like a slow-moving hinge between them. Although it is active, the Rio Grande Rift is not expected to split the continent in half or create a new ocean anytime soon. Unlike places such as East Africa, where rifting is much faster, this system moves at a careful, almost silent pace. But slow does not mean harmless. Earthquakes still occur along the rift. Most are small, but they are signs that the crust is under stress. Fault lines cut through the region, marking places where the ground has shifted again and again over long periods of time. Volcanic activity has also played a role here, especially in central New Mexico. One important volcanic feature linked to the rift is the Gemmes lineament, a zone of ancient volcanoes and lava flows. This line shows that hot material from deep within the earth has risen through the thinning crust in the past, and in some places, it may still be rising today. Near Socorro, scientists have discovered something remarkable. Deep underground, about 19 kilometers below the surface, lies a large body of molten rock, known as the Socorro magma body. This hidden mass of magma is slowly pushing the ground above it upward. Measurements show that the surface is rising by about 2 millimeters each year. That may sound small, but over decades and centuries it adds up. This rising ground is clear evidence that the rift is still alive. Heat from below continues to move upward. The crust is still adjusting. The land is still changing. Because of this heat, the region also shows signs of geothermal activity. Higher heat flow and unusual underground temperatures are common along the rift. These conditions affect groundwater, landscapes, and even future energy possibilities. In many places, it stretches about 50 kilometers across. It is made up of several large basins arranged in a staggered pattern, separated by faults. This structure explains why the land rises and falls so dramatically as you travel through the area. Many well-known natural areas lie within the rift, including Rio Grande National Forest, White Sands National Park, Santa Fe National Forest, and Cibola National Forest. These places attract visitors for their beauty, but few realize they are standing inside a massive geological system that is still evolving. Humans have lived along the Rio Grand Rift for thousands of years. The river provided water, food, and a natural north-to-south travel route. Indigenous cultures settled here long before modern cities appeared. Later, towns and cities grew along the same path. Today, major cities such as Albuquerque, Santa Fe, Taos, Española, Las Cruces, El Paso, and Ciudad Juárez all sit within the rift zone. Everyday life continues above a landscape that is quietly being reshaped from below. The Rio Grande Rift shows us that continents aren't solid or unchanging. They move, stretch, and slowly shift, even when the world above seems still. Change doesn't always announce itself with loud events or sudden signs. Often it creeps along quietly, deep under the ground. What seems calm on the surface can hide enormous power beneath. So, how did this all start? Why is the land slowly pulling apart here? And what does it mean for the world above? Unlocking the cracks. To understand the Rio Grande Rift, we have to look below the surface, where powerful forces are still at work. Even though this rift moves only about a millimeter or two each year, its slow pace hides a story of unimaginable power, stretching back tens of millions of years. Around 30 million years ago, the western edge of North America was under crushing pressure. The ancient Farallon Plate, an oceanic plate long gone, was sliding beneath the continent, pushing mountains like the Rockies skyward. But eventually the Farallon Plate broke apart and sank deep into the mantle. With that pressure gone, the land began to relax and a quiet transformation started beneath the crust. As the crust loosened, molten rock from deep inside the earth rose closer to the surface. This rising heat weakened the outer layer of the continent, making it easier for the crust to stretch and crack. Slowly, volcanoes began to appear along the rift. In central New Mexico, the Jemez volcanic field took shape, including the massive Valles Caldera, one of the largest volcanic craters in the U.S., whose eruptions sent ash across vast regions. Farther south, dark lava flows spread across the Taos Plateau, forming wide plains dotted with cinder cones. These features line up along the rift's axis, showing that the Rio Grande Rift is acting like the early stages of a continent pulling apart, a process that over millions of years could even form new oceans. Even today, the rift is alive. Mountains slowly rise and tilt. Valleys sink. Faults shift, triggering minor earthquakes that remind us the earth is never still. Over time, the basins could sink low enough for seawater, probably from the Gulf of Mexico, to flood them. One day, parts of Colorado, New Mexico, and West Texas could lie along the shores of a new inland sea. Volcanoes will continue to erupt along the rift's central line. Over millions of years, they could form a chain of islands, like the early Red Sea. As the rift widens, the crust will thin to its breaking point. Eventually, a new oceanic crust might form in the center, splitting North America in two. The western portion, parts of Colorado, New Mexico, Arizona, and Utah, could slowly drift away from the central and eastern sections of the continent. But all of this happens on a geological clock. To us, it looks slow, almost invisible. What we see now, the tilted mountains, sinking valleys, lava plains, and volcanic craters, is just the beginning of a process that has been unfolding for millions of years and will continue for millions more. Even though the changes are gradual, their impact is massive. Landscapes are reshaped. Rivers shift course. Cities like Albuquerque, Santa Fe, El Paso, and Ciudad Juarez sit right on the rift's path, living with its quiet power every day. The Rio Grande Rift is more than a geological feature. It's a living system, recording North America's ancient pressures while hinting at its distant future. Beneath deserts, valleys, rivers, and cities, the Earth is stretching and reshaping itself. Continents are not fixed. They breathe, shift, and evolve over millions of years. Standing on the surface, it may seem calm. But trace the Rio Grande, or watch the ground above Socorro's hidden magma, and the truth becomes clear. North America is alive. The rift is its pulse, marking the slow but unstoppable movement of a continent in motion. Even as cities grow and rivers carve their paths, the rift is slowly telling its story in the land. A story of stretching, sinking, rising, and constant change that will go on long after we're gone. It's a place where past, present, and future meet, where the quiet but unstoppable force of the earth shapes mountains, guides rivers, sparks volcanoes, and influences the lives of millions. No matter what happens next, the Rio Grande Rift gives us a rare look at some of Earth's most powerful processes. But before it formed, there was another shift in the continent. What exactly caused it? How did the land begin to tear and stretch in the first place? And what clues does it leave for us today? The beginning of the threat. Not every rift reaches the spectacular drama of splitting continents. Some begin boldly, only to stall and freeze in place. One of the most striking examples lies beneath Lake Superior, a failed rift that almost tore North America apart around 1.1 billion years ago. Stretching roughly 3,000 kilometers, it tells a story of immense heat, powerful forces, and abrupt halt. It all began when the core of the continent, the North American craton, started to pull apart during the Mesoproterozoic era of the Proterozoic eon. Deep beneath the surface, a massive plume of hot mantle, the Keweenaw plume, rose up, heating and weakening the crust. This surge of heat unleashed enormous flood basalt eruptions, covering vast areas with lava and reshaping the land. At the same time, tectonic forces stretched the continent in opposite directions, carving a deep valley that gradually filled with molten rock and later, sediments. The rift pushed outward in two main arms. The eastern arm extended from Lake Superior south into central Michigan, and possibly as far as Indiana, Ohio, Kentucky, Tennessee, and Alabama. The western arm ran southwest from Lake Superior through Wisconsin, Minnesota, Iowa, Nebraska, and potentially into northeastern Kansas and Oklahoma. At the center of this formation sits Lake Superior itself, occupying the deep basin left behind by the rift's stretching. Its northern shorelines in Ontario and Minnesota trace the rift's northern arc, while remnants of its volcanic activity can be seen on Isle Royale, the Keweenaw Peninsula in Michigan, northwest Wisconsin, and the North Shore in Minnesota and Ontario. Even farther south, traces of the rift appear at Interstate Park near St. Paul, Minnesota, but most of the rift's arms are buried beneath younger sedimentary layers that can be up to 6 miles thick. Scientists map these hidden reaches using gravity anomalies, aeromagnetic surveys, and seismic data. The rift's dense basaltic rocks subtly tug on local gravity, leaving a fingerprint of this ancient struggle deep beneath the surface. Yet, despite all this power, the rift never fully succeeded. Something stopped it cold. Millions of years later, geologists realized the rift's failure likely came from compressive forces far to the east, during a massive continental collision known as the Grenville orogeny. Like a giant hand squeezing shut a crack in the Earth's crust, these forces halted the rift before the continent could split apart. The result was a strange, frozen moment in geological history. Thick layers of igneous rock mark the rift's northern reaches, standing as a testament to its fiery beginnings. But most of the rift remains hidden beneath later sediments. a buried scar stretching across the continent. Its story is quiet now, but still written in the land itself, from the rocky shores of Lake Superior to the plains of Nebraska, a reminder of what almost happened. Nearby, a slightly older but related feature hints at the scale of these ancient events. The Mackenzie Large Igneous Province in Canada, spanning 1 million square miles from the Arctic in Nunavut down to northwestern Ontario near the Great Lakes. These vast regions of volcanic rock connect distant parts of North America, showing that the forces shaping the continent were immense and far-reaching. Lake Superior's failed rift is like a frozen page in Earth's restless story. It reminds us that tectonic forces can be dramatic but unpredictable, sometimes unstoppable, sometimes stopping suddenly. Even now, in its quiet, it tells us about the raw power of mantle plumes, volcanic eruptions, and the shifting forces that have shaped and continue to shape our continents. But today, a new crack is slowly forming. Could North America really split in two? How fast is this happening, and what might it look like if it continues? What signs should we watch for as the land slowly pulls apart? What scientists just found? Even today, North America is far from still. Recent research in 2025 has revealed that the continent is quietly shifting, deep beneath the surface, in ways we can't see with the naked eye. Unlike the dramatic cracks of Africa's East African Rift, these changes are subtle, slow, and hidden, but they are powerful. One of the most striking discoveries involves the continent's ancient, stable core, the craton. Scientists at the University of Texas at Austin found that blobs of lower crust are actually dripping down into the mantle. This process, called cratonic thinning, or dripping rock, happens because the remnants of the long-sunken Farallon plate are tugging on the continent from below. As the old plate sinks deeper into the mantle, it pulls the base of North America along with it, stretching and thinning the crust above. It's as if the continent itself is slowly being stretched from the inside, piece by piece. This is not just a small-scale event. The dripping crust may trigger slow shifts across central North America, subtly altering the land over millions of years. Valleys could sink, mountains could tilt, and hidden faults may quietly adjust, reminders that even the most solid-looking ground is not fixed. Further west, the Pacific Northwest is revealing its own hidden drama. In October 2025, researchers observed that the oceanic Juan de Fuca plate, sliding beneath North America, is tearing into fragments. This process is breaking the subduction zone apart piece by piece, explaining why some subduction zones shut down gradually instead of all at once. It's a slow-motion destruction happening hundreds of miles underground, invisible from the surface, but powerful enough to influence earthquakes, volcanic activity, and the long-term shape of the continent. Meanwhile, in the east, a massive zone of hot rock has been discovered beneath the Appalachian Mountains. Research published in July 2025 traced this deep heat anomaly back to an ancient rifting event, one that separated North America from Greenland around 80 million years ago. This discovery rewrites part of the continent's history, showing that the effects of long-ago rifts are still being felt today, and that heat and movement from these events can persist for tens of millions of years. Taken together, these findings reveal that the North American continent is far from static. It is stretching, thinning, and reshaping itself from below, driven by processes that began hundreds of millions of years ago but are still active today. The Farallon plate's remnants, dripping cratonic blocks, tearing subduction zones, and lingering heat beneath ancient rifts, all of these forces are quietly reshaping the land beneath our feet. For most people, the surface seems calm. Cities rise, rivers flow, and landscapes appear stable. But deep underground, the earth is alive. The crust is stretching and sagging, molten rock and heat are shifting, and ancient plates continue to influence the continent's slow evolution. What looks solid and unchanging is in fact dynamic, constantly responding to forces that operate on a scale of millions of years. This research gives us a rare glimpse of the hidden life of our planet. It shows that North America is not just a landmass frozen in time. It is breathing, stretching, and evolving. The continent's pulse is slow, subtle, and mostly invisible, but it is unstoppable. Every drip of rock, every tear in a subducting plate, and every pocket of deep heat adds to a story that began long before humans appeared and will continue long after we are gone. In 2025, scientists have shown just how alive our continent really is. From the Central Plains to the Pacific Northwest, and even deep under the Appalachians, the forces that shape North America are still moving and changing. It's a clear reminder that the Earth never rests, and the ground beneath us is just a thin layer over a vast, shifting, and endlessly active world. Could North America one day truly split apart? Or will the rifts we see today slow down and stall like the mid-continent rift?